Hi, I'm Miss Hall, and this is lesson 1.6, solving one and two-step equations. And so we're actually not going to do many one-step equations. I didn't put any on this sheet, but a one-step equation is, say, like 2x equals 8. And your one step is to do the inverse operation to isolate the variable. So if this is 2 times x, the step that I would do here is divide both sides by 2, which is the opposite of multiplying by 2, and I would get something like x equals 4. Let me do another one-step equation so you have an example. 5 plus x equals negative 3, and I would isolate the x by doing the opposite. Right now 5 is being added to x, so I'm going to subtract 5 from both sides and get x is equal to negative 8. Okay. Now let's jump into multi-step equations. So to solve a multi-step equation, we're going to simplify each side of the equation if necessary, and then use inverse operations to isolate the variables. So isolating inverse operations to isolate the variables is what we did up here. And that's the only step we did in one-step equations. What we've added in this multi-step equations is we're going to simplify each side of the equation if necessary. And you'll see that later on. Another way of saying this is we're going to simplify, perform any operations, and combine like terms. An example of like terms would be if one side of the equation had, say, like 3x plus 1 plus x, we would simplify that side to be 4x plus 1. So combining like terms or simplifying by doing, say, like the distributive property is going to come up. Distributive property. And you'll see that, right? I'm just going to use the letters for now, right? If you had something like this, you would simplify to be AB plus AC. So these are the kind of things we're going to be doing before we can use the inverse operation to isolate the variables. Let's hop right to it. Example 1, combining like terms to solve an equation. So we're going to perform step 1, which is simplify each side of the equation, right? Here are the two sides of the equation. We can simplify here by combining like terms. We have a 9x and a negative 6x. When you take 9x minus 6x, you end up with 3x. We still have the plus 15 on this side, and we bring down the negative 12. And now we have done step 1. We have simplified each side. So now we're going to use inverse operations to isolate the variable. We want to get x by itself. So we're going to start doing inverse. The inverse of plus 15 is minus 15. And then we end up with negative 27 equals 3x plus 0, so we don't have that anymore. And then right here it's being multiplied 3 and x, so the inverse operation of multiplication is division. So let's divide by 3. Negative 27 divided by 3 is negative 9 equals x. We're also supposed to check our solution. So how we check our solution, always a good job to check when you kind of math, is we're going to rewrite the equation. And where there was an x, we're going to put in the value we got for x. So negative 12. Now let's use GEMDAS over here. We need to do in grouping symbols first. We don't, but we have what these are, which is multiplication. So this is negative 81. These being multiplied are positive 54. And we bring down the plus 15, and now we add straight across. Or I'm going to start pulling in my graphing calculator, right? We can do negative 81 plus 54 plus 15, get negative 12. You see that this equation checks out. Negative 12 equals negative 12. Let's do the next one. So again, we need to simplify each side. And let's see, we have the distributive property here. 2 times 1 is 2. 2 times negative x is negative 2x plus 3 equals negative 8. Now we combine like terms. We have this term and this term are both constants. And somehow we're going to combine those to get a positive 5. So we have negative 2x plus 5 equals negative 8. Both sides are simplified. So let's start doing inverse operations to isolate this variable. We'll subtract 5 from both sides. Get negative 2x equals negative 8 minus 5 is negative 13. And this, right, is a multiplication. So I will divide both sides by negative 2. Negative 2 divided by negative 2 is just 1. I'm left with x equals negative 13 divided by negative 2 is 6.5. And we were told to check, so let's check. 2 times 1 minus 6.5 plus 3 equals negative 8. 2 times, it's going to be negative 5.5 plus 3 equals negative 8. If you want to pull out a calculator, you can. I can keep going here, though. This is negative 11 plus 3 equals negative 8. And yes, negative 8 equals negative 8. We have checked. We've checked that out. Going to the back, we have example 3, modeling with mathematics. Use the table to find the number of miles x you need to bike on Friday so that the mean number of miles biked per day is 5. Mean number means average. And to find the average, you add up all the numbers and divide by how many numbers you added. So adding up all of these numbers, we have 3.5 plus 5.5 plus 0 plus 5 plus x, all divided by 1, 2, 3, 4, 5. And we want this average to be 5. Okay, let's get to our solving equations now that we've established the equation. We can simplify this numerator by adding all these constant values. So this is 9, 14. We end up with 14 plus x divided by 5 equals 5. We have simplified as much as we can. Let's start isolating the variable. I want to do the inverse of divided by 5, which is going to be multiply both sides by 5. Right, I'm keeping the balance in the equation by doing it to both sides. 5 over 5, we'll get rid of this 5, and I'll be left with 14 plus x equals 25. And I will get rid of the 14 on both sides to get x equals 11. So on Friday, you would need to bike 11 miles to get an average of 5 per day, which, let's just look at this in context. That is wild that you have biked nowhere more than 5.5. But if you want to maintain this average, you've assigned yourself, you're going to bike a lot more than you have before, 11. Time for the try. Pause the video and unpause when you're ready to check your work. We begin with the distributive property. Get negative 8m minus 20 minus 3m equals 35. I'm going to combine like terms, so we have negative 20, negative 8m, and negative 3m is negative 11m equals 35. Let's add 20 to both sides. So I have negative 11m equals 55. This is being multiplied, so let's divide by negative 11, which will give me 1 here, and we'll have m equals negative 5. We were also meant to check our solution, so we can put in negative 4 times 2 times negative 5 plus 5 minus 3 times negative 5 equals 35. Order of operation, let's do these grouping first. So we get negative 10 plus 5 is negative 5. So we have multiplication and subtraction. We'll do the multiplications next. 20 minus, this is a negative 15. If I look at it as 3 times negative 15, so I can do minus a negative 15. Does that equal 35? And yes, 20 minus a negative 15 is 35. We have a formula that relates the nozzle pressure N in pounds per square inch of a fire hose and the maximum horizontal distance the water reaches, D, in feet. How much pressure, okay, so pressure, how much pressure, we're looking for the N, is needed to reach a fire 50 feet away. So we're given D because we're given the units in feet. That's another way to check. Our formula now will be 50 equals 1/2 N plus 26, and we will isolate N. Don't need to simplify each side, they're already simplified. Let's subtract 26 from each side. We end up with 24 equals 1/2 N. The inverse of multiplying by 1/2 is multiplying by 2 over 1. So we'll take both sides times 2 over 1, and we will get 48 equals N. So the answer here is 48, and it's in pounds per square inch. So let's do pounds per inch squared is the units, and that is our final answer.